So I'm Matt, and I work on the strategic partnerships and developer relations team here at OneInch. And today we're going to discuss cross-chain swaps and beyond. So a brief overview of what we're going to discuss. We're going to talk about our classic swaps, which is our AMM and PMM aggregation. We're going to talk about OneInch Fusion, which is our intent-based swaps. And we're going to talk about Fusion Plus, which is our cross-chain atomic swaps. And then we're going to talk about how to integrate these into your project. So, brief little overview for those of you who don't know. OneInch was actually started at a hackathon back in 2019. And since then, it's grown like crazy. We've processed over $750 billion in total volume in the last 6 years. We've seen 25 million unique wallets, and we have over 180 contributors around the globe contributing to this project. So it just goes to show that what you build here this weekend could actually blow up and turn into that next big unicorn. So let's talk about swapping. Right now, our 3 swap protocols are available on these 12 chains. And you may notice that these chains are all EVM chains. We just launched on Solana with our Fusion and Fusion Plus, and this marks the beginning of our branch into the non-EVM world, which we'll discuss a little bit later. So let's talk about our classic swap. This is our bread and butter. This is what was built at the original hackathon in 2019. Our classic swap sources swap liquidity from all popular protocols, which are basically DEXs and AMMs like Uniswap, SushiSwap, Kyber. We currently look at over, I think it's around 400 different liquidity sources. And then we'll combine these protocols to optimize the swap output. And then once they're combined and we have the most optimal route, we'll execute all of these swaps in a single transaction. So let's look at an example. In this example, we're going to look at USDC to DAI. So if a user was to swap USDC to DAI, traditionally they would just go through a DEX. In this case, Uniswap. I think right now Uniswap has like 50% of the market share, so it's still pretty commonly used. But in some cases, there might be a more sophisticated user or a user who is more price sensitive and wants the absolute best rates for their trade. And in this case, it could go through an aggregator like OneInch, and then OneInch will actually route that trade through Uniswap in order to return DAI to the user. If it's a large swap, the pool at Uniswap only has so much liquidity, so a larger swap would actually cause a negative price impact. And so in this case, OneInch can actually route it through different DEXs and different liquidity sources and split the trade. So it can go through Dodo, it can send another part of the trade through Uniswap. It can also add more complexity and send it through Curve. And then we have this cool feature called connector tokens, where it could actually swap the USDC through Curve into Tether, and then take that Tether, swap it through Sushi in order to get DAI back to the user. And it can do all 3 of these different routes. And the route can actually get infinitely complex. It can get up to like 50 different routes like this. We've seen some very large trades that have very high levels of complexity. And so you may be wondering, okay, well, it's getting more complex, right? So isn't that also going to increase the gas? And you're right, but we also take gas into account as well, and we're highly optimized for it. So in theory, if you were to do a swap just directly through Uniswap, you'd spend hypothetically around 205,000 gas. With OneInch, we've actually optimized the Uniswap router to be more gas efficient. So if you swap through OneInch and then it ends up routing directly through Uniswap, you'll actually spend only 175,000 gas. So it's cheaper to swap through OneInch and go through Uniswap than to go swap directly through Uniswap itself. And so that's our classic swap. The next protocol we have is OneInch Fusion, and this is our intents. And with Fusion, the user submits a swap with a request with a signature. And then after that, a Dutch auction is created for the swap, which basically is our order book, and it's a unique method of price discovery. And at a certain point, resolvers will asynchronously compete to fill the order. Users are protected from MEV by design because resolvers who fill the order are professionals and they know what they're doing and how to not get front run. And the transactions are also gasless for users because the resolver actually takes care of the gas fees. So the gas fees are baked into the rate for the user. So you may be wondering, like, what is a Fusion Dutch auction? Essentially, it's the opposite of a regular auction. In a regular auction, starts from a low price and gets bid up higher and higher and higher until the highest bid goes to the winner, and that's the price for the item. A Dutch auction is the reverse of that. So the price starts at a high point and it goes down over time until it becomes profitable enough for a resolver to fill. So now you're probably wondering, okay, what is a resolver? So a resolver is a counterparty that can participate in this system and fill orders that are placed by the user. They could be a private market maker, it could be an individual, it could be a company, it could be an exchange. Basically any entity that wants to participate in this system that has the technical knowledge and the funds. And so here's a rough overview of what the Dutch auction looks like. On the y-axis, we have the rate. On the x-axis, we have the time. And as you see, that there's a top left dot, which represents the starting price. Over time, it goes down, and each different dot is a different price, eventually ending up at the lower right-hand corner where the price is finalized and the order is filled. So let's look at an actual example. In this case, we have a user who wants to swap 50 USDC to 50 DAI on Ethereum mainnet. They'll sign an order. This order will then go to the 1inch API, and the 1inch API will then post the transaction to the 1inch order book where the Dutch auction commences. So while the Dutch auction is happening, we have different resolvers that are competing to fill this order. There's a set number of resolvers. I think right now it's up to 20. And so a couple of resolvers can pass. They're basically looking at the order to see when it's profitable for them. Each resolver has their own profit strategy. The other resolvers don't know what the other resolvers' strategies are. So there's an element of competition here and a race condition to fill the order before other resolvers do. So in this case, we can have two resolvers actually fill an order. The user has a feature where they can enable partial fills. So if, say in this case, resolver 2 sees part of the order is profitable for them, they can say, okay, I'm going to take part of this order. Another resolver says, okay, I'm going to take this part of the order, and they can keep chipping away at it until the order is completely full. So here is an actual example of a swap that happened, a very large swap for 3,700 wrapped Ethereum to USDT. And you can see the line that's decreasing over time is the Dutch auction curve. And the colored dots are the resolvers that are actually filling the order, and those are the fill points. And as you can see, there's partial fills happening as the resolvers are chipping away at the order as it decreases over time. And it's a little bit difficult to see on the screen, but there is a dotted line at the top, which represents the spot price. And there's a dotted line at the bottom, kind of where the red line starts to drop dramatically. There's a dotted line there, and that represents the market price. And then at the very, very bottom where the steep red line ends is the absolute min return, which is based on the user slippage tolerance. So essentially, the market or the order starts at spot price, which is a general price that is basically pulled from like the overall market, which includes like centralized exchanges, it's like CoinGecko prices, things like that. It's not just strictly on-chain pricing. And then it goes down to the market rate, which is the actual rate you would get if you were to swap directly through an aggregator, like on our aggregation protocol, or directly through a DEX. So in this case, you can actually see that this order was completely filled above market rate. And the user is actually able to receive more tokens than if they would have just run this trade through a DEX. So that's actually a really cool feature about this, is that it highly optimizes prices for users. So then the next question is, okay, well, where do the resolvers get the liquidity for this? Because we're looking at spot prices, which could be on or off chain. And, they're filling things above market rate, right? Well, this is the really cool part, is that resolvers can source liquidity from literally anywhere. They can fill the trade and then they can settle it on the back end however they want. So it could be, they could be sourcing liquidity from a centralized exchange like Binance or Coinbase. It could be their own personal funds. It could be a DEX also. And it could even be cross-chain. So, if it's a order from USDC and they've got the liquidity on Solana, but the user wants tokens on Ethereum, they can go ahead and settle the order on Ethereum and then, or fill the order on Ethereum and then settle it on the back end on Solana. And this opens the door to basically the entire world's liquidity. It includes like RWAs, which are becoming really popular this year as well. So this is a really powerful component of this protocol, and like that's why I think it's actually going to be the future of DeFi. So it's like a connection into the TradFi world. So this brings us to Fusion Plus, which is an addition onto our Fusion protocol, which we just went over. This is the cross-chain edition of Fusion. And when we were building this, we were asking ourselves, so what really matters to users for cross-chain swaps? The first thing that we really thought about was rates, because that's our bread and butter. We want users to have the best rates possible for swapping across chains. Second, the simple UX. A lot of existing bridges have a terrible UX. I think the last time I swapped on Allbridge, going from Solana to Ethereum mainnet, it took like 20 minutes, and I lost some money to fees and like price impact. If you're trying to swap out of an optimistic roll up back to mainnet, it takes 7 days. I mean, that's just crazy. That's like Western Union, which we're all trying to avoid. So we wanted to have a simple UX, and then also trustlessness. A lot of existing bridges have a contract where you pool a ton of funds into, and you have to trust that it's not going to be exploited. We've seen some of the biggest exploits in our industry have happened from bridges that are pooling funds together. Also, a lot of users will use centralized exchanges to actually bridge their tokens as well, which is really risky because then they're handing their tokens custody to the exchange and then waiting for the exchange to send it back on a different chain. So we needed a trustless system to facilitate this. So this is where we introduced hash time lock contracts. And this concept's been around for a long time. I think it was even mentioned in the Bitcoin white paper, but it hasn't really been used yet. Hash time lock contracts are essentially smart contracts that hold funds, and they require some secret S to unlock these funds. And they also expire after a set amount of time. So an example of a general hash time lock contract is a user has a secret, and they can create a hash with that secret and attach it to a contract. And if someone else wants to come and withdraw money from that contract, they can't because they don't have the secret. So the secret is the key that unlocks the funds out of the contract. That said, the user can share the key with someone else, and then that someone else can go unlock the funds. And that's kind of the core concept of our Fusion Plus and how this works. So let's look at an example. We have the user, and it's just like a classic Fusion swap. They're swapping 50 USDC to 50 DAI from Ethereum to Base. The user signs the order gets sent to our API. The API then posts it to our order book, and the Dutch auction commences. The resolvers will then compete to fill the order. In this case, we'll just say one resolver filled the order. By filling the order, we'll actually create the source chain escrow and the destination chain escrow contracts. And when they do this, they also assign a security or safety deposit to the contracts. And this is a very small deposit, about the amount of gas, which is a safety mechanism that allows other resolvers to come in and fill the order if resolver 2 fails anywhere throughout this process. And so the resolver creates both contracts on both chains, and then they're able to deposit funds from the user's wallet because the user submitted an approval into the escrow contract. And then they deposit funds from their own wallet into the destination chain contract. And once everything's good, we have a relayer service that looks at all of this. And it's looking at both contracts, and it's saying, okay, is the correct amount of source chain tokens in the source chain escrow contract? Is the correct safety deposit allocated? Have the finality locks passed, because there's a finality lock on each contract after it's created to prevent chain reorgs. Does everything look good? And if it does, then the relayer will then go to the user and ask the user to share the secret. The user shares the secret with the relayer, and then the relayer will then share the secret with the resolver. This allows the resolver to then unlock the funds from both contracts and facilitate the swap. There's an exclusivity period where resolver 2 has a brief amount of time to actually facilitate this and use the secret to unlock both escrows. If they fail to do this, the secret then becomes public to all the other resolvers. And this allows any other resolver to step in and actually complete the order on behalf of the failed resolver. So it's a sort of fallback mechanism. So the cool thing about this, it's not limited to just EVMs. We have Solana that we just launched 2 months ago. And that's actually the basis for our biggest bounty, which we'll talk about here shortly. So how do you integrate 1inch into your project? Well, we have a developer portal, and we also have some 1inch SDKs. With the developer portal, it's our official hub for integrating 1inch into your projects. And it'll give you access to the API keys, and we have documentation and some examples that you can use to plug and play into your project. The URL is portal.1inch.dev. I'll give you a QR code here at the end, so that way you can scan it. Here's a quick overview of our site, what it looks like. You sign up here. On the dashboard, you're able to see your API keys, your 24-hour requests, and a summary of all your activity. Here's our documentation site. You can see all the different APIs that we have access to. There's some swagger in there that you can play around with also. And we also have some SDKs that we recommend using, especially with Fusion Plus, because there's a lot of call data involved. So we really wanted to help simplify the interaction here. It's written in TypeScript and Golang. We're going to have more languages available here shortly. One thing to note, if you are sending an API request from a front end to our API, you'll need to use a proxy. And this is basically to prevent your keys from being leaked in the headers. So if you have your front end and there's a 1inch API, you don't want to do it directly. You basically want to have a proxy and then the API, and then you can interact with the contracts. And if you don't use a proxy, you're going to get a CORS error or some other weird errors also. And it's kind of confusing because the error doesn't really explain much. So yeah, if like you're experiencing errors, it's probably like a 5 out of 10 chance that you're not using a proxy. And our superstar DevRel, Tanner, actually made his own proxy that you guys can use if you go to this repo. This will also be linked in the QR code at the very end, so you don't have to take a picture of it. And it uses Vercel. It's cloud hosted. Basically, it's like a free plug and play, one-click solution, so you can just use his proxy to streamline your whole building process. And also worth mentioning are our other APIs. We have Spot Price API, Balance API. We also have a Portfolio API, which you can use to track your users' P&L. So you can see how much money they're losing on their meme tokens, or making, hopefully. So our bounties are the non-EVM extensions for cross-chain swap. This is $12,000, our largest bounty. We're basically looking for any implementation of Fusion Plus on a list of non-EVM chains. If you go to our bounty page, you can see a full list of what we're looking for. We basically just need you to create 2 escrow contracts, one on an EVM chain that we support, and then one on any non-EVM chain. And we need to actually see a physical transaction that happened of the funds being deposited into the escrows and withdrawn, with a link to the block explorer. The second one is extending our limit order protocol. And this is actually pretty cool. You can build some really neat trading strategies like take profits, stop losses, trigger orders. We also have pre and post interactions. So you can build some complex transactions like swapping USDC to Ethereum and then depositing that Ethereum into Aave as collateral. You can do some really cool, fun things like that. And then the third one is our smallest bounty for $1,500. Up to 5 teams can win $300 here. And it's just for usage of any one of our APIs. So, if you're pulling a wallet balance or checking some token data or looking at NFTs, that will qualify you for this bounty also. So thank you guys. That's pretty much the presentation. Again, here's the URL and here's the QR code that has links to our documentation, our dev portal site, and more. And yeah, if you guys have any questions at all, I'll be out back. And yeah, we'll also be at the booth later tonight. So feel free to stop by. And if we're not at the booth tonight, go to the 1inch Discord and ping Balak because he'll be up all night tonight. Thank you.